Hello, welcome to the first of a series of videos describing my integration of the ESP32 by example kit, or EEK, and the StackChan. So on the left here, I have an Arduino IDE window open to the drone controller. It's running on the EEK, and then on the right here, I have a IDE window that shows the code that's running on the StackChan itself. And we'll be going through the code here shortly, but I want to show you where the code lives. So it lives as a GitHub project under my ID, JJS357, with the name EEK_M5Stack. So this is the landing page. And as I scroll through here, there's some information about the EEK and the StackChan. And the fact that we're also using that comes with one version of the StackChan. We're also using the StackChan controller device, which is based on an M5 stick C+ hardware, also from the M5 Stack company. And then there are various subfolders here, one for the EEK, and then there's a README overview of the EEK controller. And there's actually two controllers here, one of which controls the StackChan running as a drone simulator. This is the top image. And then the second one shows the EEK controlling the StackChan, but now the StackChan is enabled with its own servo and camera capabilities, not acting at all like a drone controller. So there is this version of the EEK, and that's what we're going to be concentrating on in this video. And then if I go just briefly show the StackChan controller, which we'll be covering in a future video, this is what it looks like side by side with the StackChan. So in the first picture, it's the drone controller version of the stick hardware, and then in the second picture, it's the stick controller operating against the StackChan, where I'm using its native StackChan features, its camera view, and its ability to have the servos moved. So let me go back to the Arduino code. And I'm not intending to go into a lot of depth here with this walkthrough, thinking that any interested person would go to the GitHub project and clone it to their computer, and then they can examine the code at their heart's content. So let me start on the right with the StackChan. Now this code is not written natively for the StackChan. It was written for a device called the Cheap Yellow Display, CYD, which is basically a TFT screen, 320 by 240 dimensions, and then as a circuit board that's connected to the screen, there's an ESP32. So in the EEK box, if you buy that from Elector, then you would get a CYD, and then that CYD can function as a drone simulator. So I thought for kind of an extra kind of special connection, I was going to go and use the StackChan hardware, especially since that might have some long-lived capabilities in the ecosystem, because it also has the ability, the StackChan that is, has the ability to kind of serve as an AI agent of sorts and an AI assistant of sorts that you can explore by looking around the internet, looking at YouTube and so forth. And eventually I might do my own video of that, because I have had some fun using the StackChan in that way. So again, this is code not written for the StackChan, but it's code that's been adjusted to work on the StackChan. And I'm using the header file that is published by M5 Stack. And in the beginning here, I have these arrays, which are basically setting up virtual LEDs. And those are squares, square regions that we can illuminate in color or turn off individually. So they're either on as a square of color, or they're off as black. And so these are used to indicate when the drone controller is affecting parts of the drone simulator. So we have the ability to go forward and back, the ability to go in the drone simulator right or left, and then the ability to go up and down, and the ability to go counterclockwise and clockwise. So those coordinates there are where the virtual LEDs appear on the StackChan simulator. Again, we'll see demos of all of this, so don't worry to worry about seeing that later. We do name, in this case, a SID, an indicator for the Wi-Fi connection, and we can name this whatever we want. And in this current situation, I've named my SID tello-CSS-JSO because I want this to be a simulator of a real tello. And in fact, the controller software over here on the left, the EEK, can control either the drone simulator or it can control a real tello. All we have to do is change the SID that the controller connects to. So a lot of this code, again, I'm not going to go into it here, figuring that if you're interested, you'll go and get access to the GitHub project. But there, as you'll see when we run the demos, there is LED, a virtual LED at the top of the display. Those are the squares of color. And then there's also a text area where we print messages. And sometimes we want to print long messages, in which case the font needs to be small. And in other cases, we can print fairly brief messages, in which case the font can be bigger. So we have these two refresh text areas. And then I could even make the virtual LEDs be fainter or brighter depending on the strength of the signal I'm trying to emulate. So when I'm doing drone control, sometimes things are high, settings are high, and I want the LEDs, the virtual LEDs, to be brighter, and then sometimes the values are lower, in which case I want the virtual LEDs to be less bright. We also have a battery indicator for indicating how strong the battery is. And this is a real battery running on the StackChan. That's one of its features that the CUID doesn't have, is that it actually has a battery that you can run the device, StackChan device, not connected to the computer. And then since we're running Wi-Fi, then I can connect my controller to the StackChan. And then I have a little bit of animation effects that, again, I'm not going to show really here. And then the main thing is that when I send a command from the controller, and I'm going to look at the controller code in a minute, then this drone simulator needs to act like a tello. And virtually the main areas where things happen is in a radio command response function. And that's what this function is, RC response. And I just basically adapted this to the same code that I understand the tello API to be implementing. So we have pitch and throttle and yaw and roll, and then we can react to those commands coming in from the controller. We also have the ability to change the actual SID being used in the Wi-Fi connection. Typically we set this and forget it, but I mean we can change the SID. And then we need to kind of see on the surface of the screen of the StackChan which of the squares of light are standing for which actions that the controller is making against the simulated tello. So these are the labels for those controls. We have some buttons that affect the landing, and we also have the setup where we set things up to use the virtual screen that's part of the StackChan. And then if we're not connected, we offer the user the opportunity of connecting to the StackChan. That's what this function is doing. And then again, there's some complexity here that I'm, of course, skipping over rather. And then this is the main loop. This is what processes commands coming in from the outside. So a real tello has a little effect of having the motors turn on with not enough force to actually take the tello off. And there's a motor on command that you can send. And so I'm implementing a motor on feature here by just toggling the virtual LED for takeoff, for being in the air. And then we're sending UDP messages. That's exactly how the tello works. It accepts traffic from the controller, and that can be the commercial tello controller that you implement on your phone, your iPhone or your Android phone, or it can be the UDP messages coming from the EEK or the StackChan controller for that matter. And then again, not going over the details of this, but every single command that comes in is parsed, and then depending on the command that is read, then the drone simulator does something on its screen. Again, nothing, of course, is taking off. This is completely stationary on the table or on the bench. But we do something in response to every single one of the commands. So again, not going into the details of how these commands are processed, But as you can see, there's a very long else if sequence here that responds to the UDP messages that are sending the messages in from the outside. So that's the StackChan. In fact, I'm having it run here on the side here. So every, I guess it's 30 seconds or so, the controller sends a battery request message, a status message, and then the StackChan simulator, drone simulator, reports the fact that it received the battery question mark command. So over here now, I'm going to the left on the display screen, then this is the EEK drone control. And once again, I'm not going to go into detail here, but this has got a different organization than the drone simulator. This has got 4 files. The main sketch file is an INO file, as Arduino files always are. But then I'm supporting the functions and execution in the main file, the INO file, with 3 header files. Now, these are not strictly speaking headers because there's logic inside of these headers. I actually have procedures that are defined as these headers are integrated. And as long as you have them in the same folder, the same folder level that the .ino file is in, then all of these support the main functioning of the drone control. Now, this is born of my attempt to control a real tello. And I've made it simpler over really a couple of years now, and then came upon this 3-file organization to kind of allow me to have different versions of the controller set up to do different things. So one of the versions of the EEK controller can admit gamepad connections like a PS4 or an Xbox controller, gamepad controller, and then I can use that hardware to control a tello simulator or a real tello. So the comment is where I do all of my declarations. And the EEK does not have virtual LEDs. The EEK just has real LEDs. And then the EEK also has real switch connections, push button switch connections. So I have to define what the GPIO numbers are for all of those connections. And then those are all the declarations. And then there's a header file where all of the flight functions and the supporting functions to flight are included. So these are called from the places they need to be called. And again, I am clearly going down and not spending any time here. Some of the buttons in the EEK, though, can run pre-planned flight patterns. So here's a code file or code function called run flight plan. And then if I pressed a certain button, then this flight plan function will be executed against either the tello simulator or a real tello, and that means it can do automated flights. So again, that's not something you can do with a real tello controller, the one that you put on your phone, but this is something that you can do off of the EEK version of the controller. I have a couple of these, a counterclockwise circular flight, a clockwise circular flight. These are all drone functions that are in this header file. And then there is a separate header for setting things up Wi-Fi wise. And again, this code is maybe a little complicated looking, but over the years, I've found that using the event-driven Wi-Fi connection process is just more controllable and repeatable than just using some of the primitive ways of getting an ESP32 to get on a Wi-Fi network. So again, not going through the details here, but this is something that's been created out of some years now of experimentation trying to get the tello functionality to get completed. And then the main sketch file just has the setup function in it. And the setup function basically initializes the OLED display, which is that square rectangular image that you saw in the photo from the GitHub project. And then it also initializes the MPU. So there's an MPU 6050 that's on the EEK, and then that's what allows us to do gesture-controlled flying of a real tello or the tello simulator, and we have to initialize the MPU 6050. So again, this is nothing new for the StackChan. This is all logic that was created in terms of trying to have the EEK be a controller for a real tello, or later on I was controlling the CYD tello simulator. And then the loop basically just processes the buttons and processes the switches. So two of the switches are organized as buttons. In fact, the takeoff button is a button that is processed through the button 2 library, and the kill button, which is a button on the EEK, is also processed as a button in the as a button 2 library function. But the other 4 buttons, the up, down, CW, CCW, we read their states natively. And if I press down on the button, then the pin goes high. If I press down, if I release the button, the pin goes low. So we're reading the state as we go through the loop, basically every millisecond as the loop repeats. And then depending on what the state of the buttons is, we can execute commands against the telesimulator. And then later on, that's the control for the buttons. And then later on, we have the control for the no, I'm sorry, I'm too low. So I have the buttons and then I have the MPU control. So allowing us to do a pitch and roll based flight patterns based on the MPU angles that we can tilt the MPU to show. And then at the bottom here, I have the logic that says what happens when I'm not actually physically flying the telo. And so if the button is high, but I'm not in flight, then I can run a flight plan. I mentioned that in an earlier part of this walkthrough. So down here, I'm running the actual telo controller. I've connected that to my Mac, and I've connected the StackChan simulator to my Mac. And just as an end to this video, I'm going to do a little bit of flight motions here. So I'm going to press the takeoff button. Again, I'm not showing this live as a camera view, but I'm pressing the takeoff button. And you see in the serial monitor that the takeoff button was pressed. And over here in the drone simulator, we have that the takeoff button was pressed. And then now I'm going to press some of the other buttons. I'm going to press the up button. And we see that RC command, which basically says go up. And then when I release the button, then it goes back to hover mode, which means that the real telo, would be now hovering. Then I can have the telo go down, or the telesimulator simulate going down, which means the LED on the faceplate of the simulator, shows the down motion. And then I release, and then I can do the same thing for yaw. So I can do to the right, so this is clockwise motion and release, and then I can spin to the left, which is counterclockwise motion. I guess counterclockwise is to the right, and clockwise is to the right. Just mix myself up there. And I think I'm going to stop here because I kind of gave the overview that I want. In the next video, I'm not going to compare the controller to the simulator. I'm going to compare the controller logic that runs on the EEK with the controller logic that runs on the M5 stick version of the controller.